Now we'll discuss the first problem from day 6, that is intersection point of Y linked list. So what is given in the question? Given the head of the two singly linked lists, these are the two singly linked lists, we have to return the node at which the two lists intersect. So we have to return the node at which the two lists intersect. If the two lists have no intersection point at all, return null. If these linked lists do not intersect at any of the nodes, we have to return null. For example, the two linked lists begin to intersect at points at node C1. So we have to find if the two linked lists intersect or not. So how will we solve this question? So this is the theory given for the question. The test cases are generated such that there is no cycle anywhere. So it is the guarantee given by the question that there is no cycle in the entire linked list structure. Note that the linked list must retain its original structure after the function return. So we cannot change the linked list, and these are all the conditions given for the questions. The input to be judged are given as follows: intersect well, the value at which the node where the intersection occur, there is 0 if there is no intersection point. List A, the first linked list. List B, the second linked list. Skip A, the number of nodes skip ahead in list A. So this is the theory given for the question. We have to just find the intersection point of the two linked lists. So how will we solve this question? So what is the approach to solve the problem? So we are given the linked list A, that is this linked list B, that is this one. So how will you solve this question? So what we'll do, we'll maintain a hash map. So we'll maintain a hash map and we'll store the address of the visited node in the hash map. So what we'll do, we maintain two temporary pointers pointing to the head of each of the linked list. So for the linked list A, the pointer is C1, the temporary pointer that will be used to traverse the linked list, and for the linked list B, let C2 will be the pointer, temporary pointer that will be used to traverse the linked list. And what we'll do, we'll we'll store the address of the node in the linked list, because the value can be same. We'll store the address of the linked list, and at every point we'll compare if the particular node address exists in the linked list or not. If it exists, if it is visited, we'll say that it is the particular node at which both the linked lists meet. So it would be more clear when I will show you the test case. So this is the address of the linked list. So let's suppose this is the temporary address of the linked list, 700, 800. So what we'll do, we maintain two temporary pointers pointing to the head of the linked list. So we'll compare, is C1 present in the hash map? No, C1 is not present in the hash map. So what we'll do, we'll store it in the hash map and move to second point. Okay, we'll store the address of this node in the hash map and we'll move to the next node. And for the and this is done simultaneously. For the list 2 also, we'll compare if the address of the node C2 is present in the hash map. No, it is not present in the hash map. So what we'll do, we'll store it in the hash map and move to the next point, next node. So this is the next node. Now we'll compare if is C1 equals to C2. No, it is not the case. So another case, what we'll do, we'll check another case, is the address of the node C1 is present in the hash map. No, it is not the case, because 800 is not present in the hash map. So what we'll do, we'll store the address of the current node in the hash map, because we have to mark it as visited now. So we'll store it in the hash map and we'll move to the next node of the linked list. So C1 will point to this point. Now we'll compare, is C2 present in the hash map? No, C2 is not present in the hash map. So we'll store the address of the current node in the hash map, store the address of the current node in the hash map, and moves the pointer to the next node. So the pointer will move to the next node. So C2 will point to this node. Now we'll again compare, is C1 and C2 points to the same node? No, this is not the case. C1 and C2 does not point to the same node. So now we'll compare, is 400 the address of the node 8 is present in the hash map? No, it is not the case. So we'll store it in the hash map, and points, and this pointer C1 will point to the next node in the hash map. So C1 will point to this. Now we'll compare, is 300 present in the hash map? No, 300 is not present in the hash map. So what we'll do, we'll store 300 in the hash map and move our pointer to the next node. Move our pointer to the next node. So C2 will point to here. Now we'll compare, is C1 equals to C2? No, it is not the case. So we'll check, is the address of the node that is pointed by C1 is present in the hash map? No, it is not the case. So what we'll do, we'll store the address of the node pointed by C1 in the hash map and move our pointer to the next node. Move our pointer to the next node. So C1 will point to this node. And now we'll compare the, if now we'll compare if the address of the node pointed by C2 is present in the hash map. Yes, it is present in the hash map. So we have found the node at which the two nodes intersect. So it is at the address 400. So we'll easily get its value. So so the two linked lists intersect at point 8. So now we'll look at the code. So now we'll discuss the C++ code for the given question. So this is a function get intersection node that receives two parameters, the starting of both the linked list, and our function returns the node address at which the two linked lists intersect. Okay, so if any of the linked list length is 0, so we'll return the null pointer because we have to return the intersection point now. So if any of the linked list is of length 0, so there might not be the intersection point, so we'll return null pointer in both the cases. And if neither of the case will satisfy, what we'll do, we'll maintain two temporary pointers, one pointing C1 pointing to the head of the linked list A and C2 pointing to the head of the linked list B, and we have maintained an unordered set that stores the address of the node. Okay, so it is our answer variable that we have we will return from this function. So we have used a while loop, and in the while loop we are taken two conditions. If C1 points to the end of the linked list 1, we'll return we'll end this loop, and if C2 points to the end of the linked list, if any of the condition will satisfy, we'll end this loop. Okay, so this is the terminating condition of this loop. So in the loop, what we are doing, we are comparing the address of the nodes pointed by C1 and C2. If the nodes pointed by C1 and C2 are the same, we have found the intersection point, we'll return it, and we'll move out of the loop. Okay, again again what we'll do, if this condition do not satisfied, what we'll do, we'll check if the current node pointed by C1 is stored in the unordered set. If it is stored in the unordered set, we have find our point of intersection. So we'll store the address of that node into our answer, and we'll break this loop. Similar condition we have applied here. If the node pointed by the pointer C2 is found in the unordered set, so we have found the intersection point, so we'll return, we have found the answer, so we'll break this loop, and we'll break this loop, and we have found our answer. And if none of the above mentioned conditions satisfied, we'll store the address of both the nodes in the unordered set and moves to the next node. So this loop, this loops do this thing. Okay, if any of the node So if any of the pointers C1 or C2 points to the end of the linked list, we'll terminate this condition. And we have maintained the secondary conditions if C2 length if C2 points to the end of linked list 2. Let's suppose the linked list 2 is of smaller size than linked list 1. So C2 will point to null and this loop will terminate. So we have maintained a secondary loop to check the condition if at any point C1 and C2 becomes equal. C1 or C2 or C1 C2 नहीं. If C1 points to the node that is the intersection point of any of the linked list. Similar condition we have applied for C2. If the linked list 1 is of smaller length, then C1 will points to the end of the linked list and this loop will get terminated. So we have maintained this secondary condition to find the intersection point of the linked list. At the end we'll return the answer. Okay, so this is the code. If you have any doubt, please feel free to ask in the comments. Okay, and this is one of the approach to solve this problem. The next video I will discuss the second approach to solve this problem. Bye. So what is the optimal solution for the problem intersection point of the linked list? So we'll first mark our linked list. So this is the linked list A, and this one is the linked list B. We have to find the intersection point of these two linked lists. So what we'll do, we'll find the length of linked list A. So we'll find the length of linked list A. We'll find the length of linked list B, and which of the linked list is bigger in length. We'll calculate the absolute difference between the length of the bigger linked list and the smaller linked list, and we'll calculate it. Let's suppose it is equals to skip, and we'll skip the number of nodes. We'll skip the number of nodes that are more in the linked list that have the greater length. We'll skip the number of nodes. Let's suppose for this example only, what we'll do, let me copy this example. Let 4 1 8 4 5 and 5 6 1. So this linked list that is the linked list A has a length of 5, and this linked list has a length of 6. So what we'll do, we'll find which one of the linked list is greater and find the absolute difference between the bigger length of the bigger linked list. We'll find the difference between the length of the bigger linked list and the smaller linked list. So we'll find the difference. That's 6 minus 5. We'll calculate it and store it in a variable, and we have to skip these numbers of node from the bigger linked list. So this one is the bigger linked list, so we'll skip one node and starts comparing the value of the node and starts checking for the intersection point of both the linked list. For the smaller linked list, we'll start finding the intersection point from the head of the linked list, and for the bigger linked list, we'll skip the difference of the length and start checking for the intersection point. So this is the approach we'll follow. So let me show you the code and then we will discuss this example in more detail. Now I will explain you the C++ code for this question. So what is given in the code? We have the same function as we have discussed earlier. It has received two parameters, that is a head A and head B. If any of the linked list is of length 0, we'll return null pointer, because there will be no intersection point between the two linked list. And if neither of the case will be satisfied, we'll calculate the length of both the linked list. So we have maintained two temporary pointers to traverse the linked list A and traverse the linked list B. So we have used C1 to traverse the linked list A and C2 to traverse the linked list B. And we have maintained two variables, length A and length B, to calculate the length of both the linked list. Okay, and we'll find the linked list that has the greater length. We'll find the linked list that has the greater length, and we'll calculate the difference. Because these are the number of nodes we're gonna skip in a linked list that has the greater length. Okay, so we're gonna find the linked list that has the greater length. So this if else conditions will help you to find the linked list that has the greater length. Then we will calculate the difference of the length of the two linked list, and these are the number of, and when we find the difference, we're gonna skip the number of nodes, the difference number of nodes in the bigger linked list. And at the end, what we're gonna do, and here what we are doing, we have skipped the number of nodes, the greater number of nodes in the bigger linked list. We have skipped the difference of nodes in the bigger linked list. So now the length of our two linked lists become the same. So we'll start checking for the intersection point in both the linked list, and if we found the intersection point, we'll return it. Okay, so this is the submitted code. So if you have any doubt related to the question, you can feel free to ask doubt. Okay, bye.